All right, so I want to go over the tasks and event management system that is being used for RTS21. So what is that? Basically the challenge is that units need a standard form of control between both the player and the AI that can also control sequences of steps. Basically, we're splitting apart everything that a unit can do into a series of tasks, which can include tasks like wait, idle. It can include a task like move to a target location. It can include a task like pick up an object. There's lots of tasks that it can include, or attack or battle. There's a lot of different things it can do. So let's get into how exactly this works. And you can take a look at it in the Architectural Digest for a shortcut to it, but and there's also another document that I'll include the links for where I go through the individual tasks, and as we add different types of tasks, we'll need to add them here. And also, if there are any new steps that we add, features and capabilities to the task system, those should be noted in here as well, as this one gives more detail on what we can do. Okay, so let's jump over to Unity. So in Unity, I'm going to play, and I just upgraded, so hopefully everything's good, and so far it looks fine. Okay, I'm zooming out far enough because I wanted to show this drone, but I also wanted to show this rock over here and this other rock over here that are defining 2 points. If I click on the drone, which is this one, I believe, it has a tasks object to it. The tasks gets attached to a unit. A unit can be a building, but it can also, it's typically going to be or it will be buildings, it will be drones, it'll be tanks, anything that we can control or give behaviors to. Okay, and you'll see inside it, it starts with patrol 2 points. Now this is an AI, this is a not an AI, but it is a task which has a loop of tasks inside of it, a series of tasks that loop. That patrol between 2 points. So I'm going to activate this. And when I activate this, you can see that it runs. The task system in general is executing, and it's been starting to grow. And so I wanted to have some kind of overview to go through this. But you can see it comes over here, and then it heads to a rock, and then does something, and then makes its way back to the other rock. Now you can see it says going to point 1. When this gets there, it's going to change. Pickup animation. And then go to point 2. The pickup animation only lasted for 0.7 seconds, so you could barely notice it. It'll change again right about now. And it did. And now it's going back to point 1. So that continues forever in the game, unless it gets interrupted by something. Which honestly, I don't know if I've finished putting in the interruption commands. Okay, so it got to here. Alright, so yeah, the interruption commands are not fully functional yet. So if I interrupt a task, it can't go back to it yet. Okay, so let's go ahead and take a look at how the task system works. To begin with, I'm going to click over here to patrol 2 points, and when I do, you can see it's highlighting patrol 2 points up here. So I'm going to select that. And you can see the path, assets, RTS21, data, AI. I'm calling it AI here, but I'm probably going to change the name to tasks because this is a series of commands. There's nothing intelligent about this. These are just the instructions that have been given it. Those instructions changing over time would be the AI. Okay, but it has a move animation, which we didn't even see. It has a go to point 1, then it has a pickup animation. Now, if I click on these, you can see that they actually represent other things. So this move animation represents a move over here, and it's got a duration of 0.001 seconds, or something equivalent to 1 frame out of 1,000 frames per second, if it were to get up to that speed. But the idea is that this is not closing out an animation. This is only telling it to start an animation, and then the duration is how long it waits before doing the next step, which in fact I could put at 0, and I will do that. Okay, so move animation is set to 0. As soon as it sets the animation, it will move on to the next step in the task. Okay, so the next one is the go to point. And this is literally just giving it a target, which right now I just used a hard-coded location. I'm using hard-coded vector 3. Ideally, I would probably use a transform, but either could work. When I right-click on a map, there's nothing for it to pay attention to, so a position is going to be the most common one that I'm using there. When I'm right-clicking to have it target to attack or follow another unit, then I'm going to want a reference since that position can move. But I haven't gotten to that point, so I don't have anything in here for it. But basically, this just acquires the nav mesh agent and tells it to go to this point, and it can stop once it gets within this much distance of it. And last one is the pickup animation, which is, it calls an animation called pick_up, and it lasts for 0.7 seconds before it releases to the next task. So let's take a look at the code now. So when I click over on the drone and in the tasks, I see this tasks. So let's open that up. And inside of here, I see a tasks mono behavior. Now it is expecting something. This expects, so let's require component, and inside it wants type of, and this one was unit. It's expecting a unit to exist, so it wants to be on the same thing. So we have a public unit info, and since that's required, I decided to just add that as a required component now, just to clean that out and not have to worry. Okay, so this gets attached to an existing unit, and which one was it? The tasks. So it means that it can now accept instructions. Now there are instructions that will require very specific things, like very specific other scripts to be on a particular object, or even expecting a very specific model. The drone is very flexible. The drone can take care of construction, repairs, all sorts of different things, so use of its hands might be taken advantage of. Tanks don't have hands, so some tasks you could potentially assign a task to a tank that has no idea what to do with it and wouldn't work. But the basic idea is that this is a list of instructions that it's going to execute an instruction, wait for it to complete, and then move on to the next one. But it has a list of them, and you can interrupt them. You can add new ones to the end, so when it's done doing whatever it's already in line to do, it'll do these additional tasks. And that's append, if you were to append. It's got inject, which basically says, okay, you have things you're in the middle of doing right now, but do this thing first. And basically what that does is it still finishes the task that you're on. It still finishes the task that you're on and then moves on to the next one. However, that's not true. No, that's not entirely true. It lets... There's some gray area in this. It should be completing the task or ending the task instantly when something else is injected here, because this could be you're in the middle of doing something and you get attacked. So if you're getting attacked and your unit is continuing to head across and it's a drone that's defenseless relatively, then they need to be able to change course. They need to have some sort of interruption happen right away. It can't wait till it gets to the target destination. Okay, so inject is supposed to change that right away, and there might be some bug fixes in here, but we haven't gotten to that point in the code to validate this. And we also have clear, so you can just wipe out all the tasks that currently belong to a unit. Okay, now there's no update function. Instead, we have a coroutine that's running. So the first thing we do is there's a variable for a task called start with, and we append that. So it goes onto our list, and then we start the coroutine for the task executor, which will basically loop forever while this unit exists. Okay, first thing it does is when it's coming into the loop, if it doesn't have a value, it makes sure there is no active task set and it yield returns till the next frame. If there was anything available, then instead it's going to set the active task to the first task that is available in our list, which I'm using a LinkedIn list because I want to be able to linked list because I want to be able to change and inject this stuff, and being able to alter the items inside of an array. This is going to be in common. This a linked list will be one of the fastest. Okay, so after we get our active task set, we remove the first one from our list of tasks. So we remove the one that we just got. Then we yield return the active task being executed. So we start executing it and pass it back. So all of our tasks will operate inside of coroutines. They are expecting to operate effectively during the update frames. Okay. So now we have a list of different types of tasks that can be installed on things. So I'll go to task animate because this was one of the first ones that we saw. And you can see, and it has a duration of how long, and it has an animation of idle. And I'm going to go to task first just to show you this part, but it's basically just an abstract class that has 3 functions: execute, interrupt, and clone. So a lot of the times when we're executing these, they are operating as clones, not as the original, so that once we establish a task, that task remains the same unless we clear the list or inject new ones to take over for it. Okay, so, oh yeah, and a lot of them, the tasks are based on scriptables, so if we change the states of those scriptables, it changes the state for all the instances connected to it. That's why it's important for most of these items to clone. Okay, so let's go back. So if I go back to here, I can see that we have the clone, which just duplicates this one, creates an instantiated version of this. And then from here, we go to enumerate execute, where we basically just say, hey, go find the animator in this object or any of its children and play this named animation. If the duration is set to 0, we're going to return this item. This is a special case item, so I wanted to show it right away. Task completed instantly. It is task completed instantly, and if we take a look at that, these are all throwing exceptions, but we're never using them. But it's an enumerator, so it can be returned as one of the results. And the entire purpose of it is that anything can check to see, did something return a task completed instantly? And if it did, then exit immediately, move on to the next step. Because normally if you yield return null, for instance, then it's going to wait till the next frame before it actually does the next step. But if we have 30 or 40 different steps to help set up a particular event or the start of a level or some type of thing that's happening, that's going to become difficult. That'll become difficult on the user, where if we have 30 or 40 of them, that might be a second and a half where they are waiting when nothing is happening. So it can produce a bad user experience. If we have a reason why something's going to exit immediately, we should have it exit immediately. Otherwise, it waits for the amount of seconds for the duration. So Unity handles that part. Okay, there's another one, a task loop, that was relatively common, and it just has a list of tasks. So you can put a whole bunch of them in there. As we saw in ours for the Patrol 2 points, it had 6 steps in it. And then basically we go through, when this executes, we generate a clone of every single task and we append it to the list of things to happen. So we append it to the list of things to happen, and then we append a clone of this tasks loop by itself. That way, once it executes all the steps in the task list, it finds the step for this one again, where it regenerates all those steps and executes them again. Okay, so next we have, there's a couple others in here that I'll just go over in very light detail. We can go through, you can take a look at this one. If you add new ones, you should put it in this list, and everything in here is in alphabetical order, unless I made a mistake. And it starts with task. So if you want to construct a new task, here are some of the key things that you should know about to make sure it gets set up. But otherwise, here are the existing ones. We have task animate, which we went over. We have task loop, which we went over. We have task travel to, which I didn't show you the code for, but it's just getting the nav mesh and telling it to go. There's also task face target. So after you travel to a location, you might be your object that you're looking at might be here, but you might be facing this direction. So task face target will typically follow that when it matters and have the unit point to the location. This will be really important for drones who are constructing things, so they're not facing away from something and having their arms behind them moving and manipulating stuff. Okay, then we have the other one is task take set, and literally this can pick up or place an item from a drone, or other units can use it as well. I'm trying to keep the target on this, or the hand that it's supposed to be manipulating the position of, as something that can be changed. Okay, so we could potentially use it on other units that might drop by a building and automatically have a building apply something to another unit. Okay, so next, travel to, take set, that was it. And honestly, I might come up with different names for this, or create two separate tasks out of this, one for task place and one for task grab. Those might make more sense long term. Okay, but that's the task system. So remember, we keep the lightweight explanation inside of here, the architectural digest, and then we have the tasks dialogue as well. And if they're not in here yet, I will be making sure that the links are in here. So if you're in any one of these, you can find your way to any of the others, including this video. All right.